Let us take another case of n equal to 2, that is 2 asymmetric carbon atoms, and this time we take this example. This tartaric acid. Two asymmetric carbon atoms. These two groups are similar. The first stereoisomer, in which the OH groups are on the opposite side. Its mirror image. So this is an enantiomeric pair, an enantiomer. This will be called D. As I told earlier, COH put on the top, and the OH, if it is on the right side on the lower carbon atom, then this is D. So this is D and this is L. It is on the left side. This is D minus actually, and this is L plus. Now we put both OH on the same side. This molecule, though, has two asymmetric carbon atoms, yet there is a plane of symmetry in the molecule. That is, this portion is the mirror image of this. So this molecule becomes symmetrical. This is plane of symmetry. This is not asymmetric, therefore we cannot have another enantiomer for this. By internal compensation, its asymmetry is lost. So these are optical isomers having positive and negative rotations. This is optically inactive. Stereoisomer it is, but not optically active. It is known as meso. This compensation is given the term meso tartaric acid. This molecule is related to this molecule by diastereomerism. So first, second, third, first and third second and third are diastereomers. I told you last time, diastereomers are the stereomers which are not the superimages images of each other. So, though we expect 4 stereoisomers, but this is exception here. When these two are similar, only 3 stereoisomers will be possible. You can write similarly with n equal to 3 and n equal to 4. I will now explain how to name these stereoisomers, because it is not always possible to put the prefix D or L. Only hydroxy, aldehydes and acids or amino acids and aminoaldehydes can be named in D and L way. So IUPAC dictated rules for naming of stereoisomers. In the first step, you have to decide the priority of the 4 substituents. An asymmetric carbon atom will have 4 substituents. You have to decide which is prior to the other, and for that sequence rule is made. Decide priority by the atomic number of the key atom. Key atom means the atom attached to asymmetric carbon atom. For example, if you have here OH, CH3, etc. This O is the key atom. In this case, C is the key atom. So if they are different, that is, one is I, Br, Clr and Sh, they all have different key atoms. Atomic number of iodine is higher than this, than this, than this. So this is the highest priority and this is the lowest priority if the 4 groups are here. If you have OH and CH3, you can decide that this is a higher priority, oxygen is a greater atomic number than carbon. But it is not always that all the 4 key atoms are different. 2 or 3 key atoms may be the same. If 2 or more key atoms are similar, decide the priority by the sum of atomic numbers of the atoms attached to them. Say both are carbon atoms. One is ethyl group and the other is methyl. This is the key atom. Both are similar. Now this is attached to 3 hydrogen atoms. The sum of the atomic number is 3. Here H and 1 carbon. Directly attached atoms are to be seen, 2H and this C. So here 6 plus 2, 8. So this is of higher priority than methyl group. You can decide very easily if both the key atoms are the same. Third point. Very important to note, if it is attached like this, isopropyl group and methyl amino group. This is carbon, not decided by these two atoms. This is attached to nitrogen, hydrogen and hydrogen. One hydrogen, two carbon atoms. The total here is 7 plus 1 plus 1, 9. Here 1 plus 6 plus 6, 13. This should get the priority over amino methyl group, but this is not so. In this rule, it is said that of the two systems, if any of these has an atom of highest atomic number, it will be given priority. N has the highest atomic number in this, among these. So although the total is 9, yet this gets priority. Further, if you have somewhere C double bond C, this is the key atom, then this will be deemed to be equivalent to 2 carbon atoms. Double bond, while counting you will have 2 carbon atoms. If you have C triple bond C, this will be deemed to be having 3 carbon atoms attached. Remember this rule. C double bond O is equivalent to C and 2 oxygen atoms. C triple bond N, 3 nitrogen atoms. A phenyl group, C6H5 is equivalent to so these are the rules that you have to remember. This will be deemed to equal to C attached to 1 CH, 1 C and 1 CH. And then you can count. Another thing, actual C triple bond C gets priority over this also equivalent to C triple bond C. This is actual. If both these are present, this will be given the priority, not the triple bond. And similarly, if this is present along with this, this will get priority. Phenyl gets priority over C triple bond CH. And also, C triple bond C gets priority over these 3 carbon atoms. After we have decided the priority, we will in step 2, name the compounds, and that we will see in the next video.